Hello everyone, welcome to you all. So we are continuing with the same topic, that is half wave control rectifier. In the previous video, where we have tried to explain this particular circuit and how it works. Along with that, the waveforms, that means if Vs represent the supply voltage or the source voltage, and Vt represents the voltage drop across the thyristor, and V naught represent the voltage drop across the load. Then this particular diagram we have explained what is the correlation between Vs, V naught and Vt when we have applied gate current at the gate terminal of the thyristor at an angle alpha. So in the previous video we have explained how this particular waveform can be drawn. So today our topic is something different, that is we need to do some mathematical calculations on this particular circuit, and here we are trying to do that one. So before going into that, remember I have written something here, that is Vs once again, the source voltage, that is Vm sin omega t, V naught output voltage, Vt voltage across the thyristor, Is is the source current that we will get here within the circuit itself. Now what is V naught? V naught is the output voltage that we are getting across the load. Remember, whatever diagram I have drawn and whatever calculation I will do here is for pure resistive load only. So that is very important, because we know if the nature of the load changes, then this kind of waveform will also change, along with the equations will also change. So whatever we are doing here is for resistive load only. So let's do the calculation. The first one is the V naught average. So how to find out that one? V naught average. So how to do that? 1 by t, the basic formula is 1 by t integration 0 to t v t and d of omega t, where v is the function of t. Now in this particular case we know t, the time period is 2 pi, so that is 1 by 2 pi. What is time period? We know that is the time required by each and every signal to complete a full oscillation or the full cycle. So the time period is 0 to 2 pi integration 0 to 2 pi. Vt here is, that is Vs, that is Vm sin omega t d of omega t. Now if we look at the diagram, then you can find, though the time period is from 0 to 2 pi, but actually for what time period we are getting the output? Because my diagram V naught says I will get the output during alpha to pi angle only. I am repeating it once again. The output voltage appears here during alpha to pi, in this region only. From 0 to alpha I will not get any output. From alpha to 2 pi, from pi to 2 pi we should not get any output. From 2 pi to 2 pi plus alpha, in this region we will also not get any kind of output, because this is the region during which SCR is on. That is why the output voltage is available here. So I directly can write down this one, 1 by 2 pi, I will get the value from alpha to pi only, because from 0 to alpha output is 0. From alpha to pi I will get something like this one. From pi to 2 pi the output is 0. So within this limit I need to do the integration only to get the V naught average. So I am doing that one, 1 by 2 pi integration alpha to pi Vm sin omega t. Vm is the constant term, so I will take it out from the integration. Vm by 2 pi integration alpha to pi sin omega t d omega t. Now this one is the very easy integration. Integration of sin omega t is minus cos. So put that one, Vm 2 pi minus cos of omega t, where limit is from alpha to pi. Now put that value here. We will get Vm by 2 pi, take a minus common here, put that value, that is cos pi minus of cos alpha. Now what is the value of cos pi? Okay, if you want to understand that one, then I have a very easy concept to remember that one. What is that? Everyone, all of us knows that this is the waveform of sine. Even if we cannot calculate the value, if we forget at a particular time what is the value of cos 180 or sine of 180, then no need to memorize anything, because already we know that the waveform of the sine wave is like this one. So what does it mean? It means this is omega t. So when omega t is 0, sine value is 0. At this position angle is pi by 2, that means 90 degree. Sine is maximum, the value is 1. This is pi, the value is once again 0. This is 270 degree, that is 3 pi by 2. Here the value is minus 1. This is 0. So in this case, in this way, we know the value of sine changes. I am writing here. For sine 30, sine theta, when the angle is 0 degree, angle is 90 degree, angle is 180 degree, 270 degree, and 360. If we know this one, that is enough for us. Now we know from the diagram we can find out sine 0 is 0, sine 90 is 1, sine 180 is once again 0, sine 270 degree is minus 1, sine 360 is 0. Then what should be the value of cos? What is the waveform of cos? Everyone knows that. That is, cos is basically leading by 90 degree with respect to sine. So the waveform of cos is like this one. It starts from here, as it is leading, it follows the same thing and it ends here. So that means the waveform is like this one. So what will be the value? At the 0, the value is 1. At 90, cos value is 0. At 180, cos value is minus 1. At 270, it is 0. At 360, it is 1. So in this way, cos and sine make a change between them. So coming back to the topic once again. So what is the value of cos phi here? We can write down Vm by 2 pi minus cos pi is minus 1 minus cos alpha, because you don't know the value of alpha. So it becomes Vm by 2 pi minus minus plus 1 plus cos alpha. So that is the V naught average. That is the output, average output that will we get for this particular half wave controlled rectifier when the load is pure resistive one. Now if this is V naught average, then what should be the value of I naught average? We can do it easily. That is I naught average or IS average, whatever you can write down. So remember, here as the load is resistive one, so that means voltage and current should be proportionate. So we can write down directly I naught average is equal to V naught average divided by load, that is R. So that is the easiest one to find out. I am repeating it once again. What is the relation between V naught average and I naught average? That is the relation between average value of output voltage and average value of output current. What is the relation? The relation is, as the load is pure resistive one, so voltage and current both are approximately both are changing proportionately. So that means they follow the Ohm's law, that is V is equal to IR, or V varies with I. So V naught average and I naught average will be very easy to calculate by using the Ohm's law only. where R represents the resistance of the load itself. Now the next one that we need to determine is the RMS value. So now the RMS value, that is the V not RMS, V not RMS, that is the RMS value of the output voltage that we are getting from here. So once again, as per the definition, the equation becomes 1 by T integration 0 to T Vt square d of omega t. Now do the calculation once again. T here is 1 by 2 pi. We will get the output during alpha to pi transition only. The value of Vt here is Vs. Vs is Vm square sine square omega t into d of omega t root over half. So that is the value we want to find here. So do that one. Take Vm square out of this one, so it will become Vm square by 2 pi integration alpha to pi sine square omega t d of omega t to the power half. So the whole value or the whole calculation depends upon the integration of sine square omega t. Now for that we need to apply a formula. What is the formula here? I'm writing here cos 2 theta is equal to 1 minus 2 sine square theta. That is the formula. If you can remember this formula, then it becomes easier to understand. Cos 2 theta is equal to 1 minus 2 sine square theta. Or we can write down 2 sine square theta is equal to 1 minus cos 2 theta. Or we can write down sine square theta is equal to 1 minus cos 2 theta divided by 2. So that is the formula we will use here. So put that concept here. Vm square by 2 pi integration alpha to pi 1 minus cos 2 theta. Theta here is omega t. So 2 omega t divided by 2 into d of omega t to the power half. Now if I break this one, then it becomes a little bit more easier. Vm square by 2 pi integration alpha to pi 1 by 2 d omega t minus alpha to pi cos 2 omega t by 2 of d omega t I have simplified this one into two sections. Then what will happen? Vm square by 2 pi. If I do the integration of this one, then what I will get? I will get only t. Then put that value alpha to pi, so it will become pi minus alpha by 2. I have put the value here directly. Then cos of 2 omega t. Cos of 2 omega t will be sine 2 omega t by 4, because the integration of cos 2 theta is sine 2 theta by 2, and the limit will be alpha to pi, and whole this thing is within under root. Now Vm square by 2 pi, sorry, there is the multiplied here, pi minus alpha by 2 minus, put the value here, sine 2 pi by 4 minus sine 2 alpha by 4 to the power half. Now Vm square by 2 pi minus alpha by 2 sine 2 pi, already I have done this one, sine 2 pi is 0, so this one becomes 0, minus minus plus, this is sine 2 alpha by 4 1 by 2. So I can rearrange this equation in this way. Take Vm square out of this root, so then it will be simple Vm. It will be simple Vm, and 2 pi will be multiplied here. Then it becomes pi minus alpha by 4 pi plus sine 2 alpha by 8 pi to the power half. So that is the value of RMS voltage, output RMS voltage of this particular rectifier. Now if this is V0 RMS, then once again I can find easily what is the value of I0 RMS. What will be that value? Once again, as the load is pure resistive one, so then I0 RMS will be V0 RMS divided by R. I am repeating it once again. As the load is pure resistive one, so I0 RMS will be V0 RMS divided by R. After that, now along with this, we have calculated V0 RMS and I0 RMS. After that, we need to find out something more on this particular context. The first one is output power, that is P out. P out will be V0 RMS square by R or I0 RMS square into R. That is V square by R or I square into R. The same thing that we are using here. Now the next one that we need to know here is called conduction angle of SCR. I am writing here. Conduction angle of SCR or thyristor, that is represented by gamma t. What does it mean? It means for what angle the SCR is conducting. Conduction angle of SCR means for what angle the SCR is conducting. Now from the diagram we can find during alpha SCR starts conducting, at the angle pi it ends its conduction. So during alpha to pi in this region SCR is basically on or conducting. So what is the conduction angle? This is maximum value of angle, that is pi, minus the minimum value alpha. So during this particular region or during this value SCR is conducting. Now remember, if alpha increases, suppose for this particular diagram alpha might be 30-degree angle here. If I increase, suppose I have taken alpha as 60, that means at 60-degree angle we have provided gate current to the gate terminal of the SCR. That means firing angle becomes 60-degree. Then conduction angle will be pi minus 60. So that means it decreases. If alpha is 30, then it is pi minus 30. That means conduction angle is 150 degree. If alpha increases to 60 degree, then conduction angle becomes 180 minus 60, that is 120 degree. So in this way, by varying the value of alpha, that means by varying the firing angle, we can control the output of this circuit. That is why this is called controlled rectifier. That is why the name is called controlled rectifier. We have certain amount of controllability over the value of the output that we are getting from the circuit. That is called conduction angle. Now next one is called extinction angle. Extinction angle. I don't know whether you can read it or not. It is given by beta t. What does it mean? A series of due to reverse bias condition, due to reverse bias only. So extinction angle is, we are talking about that particular angle during which a series of, remember, but it is off due to reverse bias only. So once again, we have to come to this particular waveform. So you can find a series of during this period from pi to 2 pi. Why? Because in this region, the SR is reverse bias. In the negative half cycle, SR becomes reverse bias, so it gets off. But one should think in this way, from 2 pi to 2 pi plus alpha, in this region, SR is also off. But this region is not considered in case of extinction angle. So remember, extinction angle does not say what is the amount of angle during which SR is off. If that happens, then it should be pi plus alpha, because the total duration of turning off of the SR is pi plus alpha. But here it is called extinction angle. That means SR is off only due to reverse bias condition. So SR is facing reverse bias only between pi to 2 pi. So that is called the extinction angle. So what is the value? 2 pi minus pi, that is only pi. So extinction angle is pi. Okay. Now the third one is peak inverse voltage. What is peak inverse voltage? This one, peak inverse voltage. The maximum value that has been applied in the reverse bias condition. So what is that value? During reverse bias condition, what is the value? The value of this one. That value is Vm. So peak inverse voltage is Vm, because that is the amplitude of the signal that we are applying. Because that amplitude is applied across this thyristor in positive half cycle, in negative half cycle, in the both half cycle also. But during positive half cycle, due to the application of gate pulse, it triggers. During reverse bias, we know SCR gets in turned off condition. So in turned off condition, it has to suffer a voltage applied across it, and that voltage is called peak inverse voltage. So that value is Vm. Remember, we need to put the magnitude only, not the minus sign. Don't write down PIV is equal to minus Vm. It is only Vm. Why? Because we are talking about the amplitude only, not the direction here. The last one that we need to find out here is called circuit turn off time. The circuit turn off time is this one. This period is circuit turn off time. This period is circuit turn off time. That is denoted by Tc. So circuit turn off time Tc is equal to pi by omega. So these are the important parameters that we need to derive from this particular circuit and explanation, starting from V naught average, then I naught average, then V naught RMS, then I naught RMS, then the output power, then conduction angle and extinction angle. These are very conceptual, try to remember them. And the next one is peak inverse voltage. So that is all about the calculations for half wave controlled rectifier when load is only resistive. In the upcoming video, we will try to understand the calculations and the waveform of the circuit when load is inductive in nature, and we will try to find out how a change in the load can make a difference in everything. When we will change this load from resistive into inductive one, we can find that the waveform as well as these calculations, everything will change. So that is all for today. Thanks for watching.